Welcome back. Um, Today I'll be talking about introduction to stream processing. So uh, let's go back into history and talk about big data processing. Big data processing has a long history of processing humongous amount of data into small and regular batches. As time went by, business start demanding more frequent batches or smaller batches throughout the day. As a result, the daily batches turn into hourly batches, and hourly batches turn into minute batches. As a result, we have a new invention of Apache Spark, which is a distributed computing environment where batches can be processed in many clusters in really efficient and fast manner. So, to begin our session, let's dive into a business context and learn about the role of Apache Spark in a business context. Let's say we have a trading house and it is a big trading house, stock trading house with many offices. The trading starts at 9:15 a.m. and goes until 3:30 p.m. There are lots of stock transactions that takes place between employees of the company and the customers. There is, it is estimated that there are millions of transactions that occur every 15 minutes. So when transactions do occur, they end up in a data lake within 15 minutes from terminal of the broker to the, the data lake. Now, the business is asking us to produce a report. Business is asking to produce a report where you have three different sums. One is buy, one is sell, and is one net value every 15 minutes, starting at 9:15 and ending at 3:30. So if you look at this graph, you will see that on x-axis it is a timeline from 9:15 goes to 3:30, and on y-axis is dollar value of these three sums. One is buy, one is sell, and is one net value, the difference between buy and sell. Now we have to create a Spark application that calculates these three sums every 15 minutes. How do we do this? To do this, we can start by creating a ingestion pipeline from data lake to distributed storage. Data lake is a place where all transactions are dumped from terminals. So we can start by creating a data pipeline that creates one file at 9:30 from all transactions that occur from 9:15 to 9:30. And similarly, the pipeline would create another file at 9:45 for all transactions that happen between 9:30 and 9:45. And this would go on till 3:30 p.m. As a side note, it will be fair to warn that creating file at every 15 minutes is not a practical task because of certain limitations, which we'll discuss about later. But let's assume that it is practical and we'll move forward with our explanation. Now, the second step is to process those files which is created. There are two ways to process those files. First is to read and process all. Second is to read and process incrementally. Let me define what is read and process all. So, if you choose read and process all, then at 9:30 we will read one file and compute these three sums. Then at 9:45 we'll read two files, one from the previous 15 minutes and one from this 15 minute. We'll read two files and then compute these three sum, and so on. We'll keep doing this until 3:30 p.m. where we will read 12 files and compute three sums. But the problem with this approach is that the performance degrades as hour passes by because each file contains millions of transactions, and the job that computes these three sums may not complete within 15 minutes. Okay, so this is a drawback of the approach one. This drawback is taken care by approach two, which is read and process file incrementally. In the second option, we read file. We will read the recent file. We won't read all the files, but only the recent files. So at 9:30, we'll read a recent file and compute three sums and track it somewhere. At 9:45, we'll read the most recent file, compute three sum and track it somewhere. And we'll keep doing that until 3:30 p.m. But this approach requires some housekeeping. The housekeeping questions we need to answer are: how many files do I have in a given directory? Which one I processed last time? Which one is new? What if the new file is not yet written? Should I wait or terminate for under 15 minutes? What if the current batch fails for some reason? How would I know where to start again? What if the previous batch is still running? Should I start or wait until the last batch finishes? This question exists in all batch jobs, not only in a minute batch jobs, but in all batch jobs. So this is our basic question we need to answer. Now going back to the invalid assumptions we made earlier, between 9:30 file, between file created 9:30 having all the transactions between 9:15 to 9:30. The reason why this is invalid because if a transaction is created at 9:29, then it'll take less than 15 minutes to reach the data lake. No matter how efficient the infrastructure is, the file may not reach it. The file that the transaction that was created 9:29 may not reach the data lake by the time at 9:30 when the file is created. It may reach it later after 9:30. Let's say 9:40. Then that transaction will only be included in a file that is created 9:45. So what's the implication of this? The implication of this is that the sum that we calculated at 9:30 are incorrect. So we need a mechanism to handle the late arriving record, right? So from what we know is that, from what we see is that the streaming is not a subset of batch processing. Stream processing is not a subset of batch processing, but batch processing is a subset of stream processing because stream processing presents extra challenges on top of batch processing. And the questions that we need to answer batch processing also need to be answered for stream processing. Because of this, stream processing is the superset of batch processing, not the other way around. So, just quickly recapping, today we talked about the history of big data processing and why do we have the streaming processing and what are the ways we can process the, the files to create the streaming processing. One is read all method and one is read incremental method. And we also talked about advantages and disadvantages of each of those methods. Thank you.